Hello everybody, welcome to a C++ tutorial on how to save and load games in a multiplayer game um, in C++, Unreal Engine. Currently, at the time of recording, we're on 5.3, although this should work for previous versions as well, and I assume future versions for the most part. So, first things first, we're going to go over a few under the hood um, functionality, talk about how certain things work, how saving works in Unreal. Um, as always, there should be some timestamps below, so if I start talking about something you already know, feel free to skip ahead and just get to the parts that are of most use to you. Another thing to note is that the reason I'm making this tutorial is because as far as I could see, there's maybe one written tutorial that I could find online with C++, which wasn't multiplayer, and there was one YouTube video that I found which was C++ and no multiplayer, and it was very basic. For the most part, I found that tutorials tend to just cover games that they'll kind of make 10 variables and create a random little tiny map, out of the box map, and it's just not very useful because it doesn't really go into detail about how you go about saving an actual game, a real game that you're going to make. And so, of course, your game is going to be different to this one. But basically, I'm going to try and talk about the theory a little bit, talk about my implementation, talk about problems that I've had, and hopefully, by explaining how I solve those problems, you'll be able to understand how to figure out your own. So, without further ado, let's get into it. So, first things first. The way that Unreal saves games, or the way that Unreal Engine saves games, is to basically take data from your objects and to serialize them into Unit 8, basically SAV files, which are kind of like slightly jazzier um, TXT files. But basically, it reduces all your data to numbers and letters. And in order to do that, it does some magic behind the scenes, which I don't fully understand, but don't really need to. So what you can do, the first thing you should do when you're thinking about saving a game is to go into all of the classes that you plan on saving, all of your objects that you plan on, the status of which you plan on saving, to go through variables and basically to mark as a U property. Let me find an example as save game. Have I opened up the wrong one? Wait, okay, let me just search for it. Do I have any in here? Yes, I do. No, I don't. Here we go. Here's one. So this is saving a map. So you can write as a U property and then just do save game. And it will automatically, kind of automatically, I'll tell you how to make sure it's automatic, save that particular variable. Now, the problem is that when you have native data types such as ints or floats or bools, that's no problem. That's completely fine. The engine understands how to save those, how to serialize those. The problem is when it comes to pointers to objects. Because basically when you load a game, you are recreating an object. It will have a different memory address, and therefore that pointer will be completely useless. So the difficulty in saving games is firstly separating your variables into native data types and pointers, and then figuring out a way to make those pointers savable. So that's the first thing. So you go through and just make sure that you're not entering save game to any pointers except classes. Classes are slightly different. You can kind of save those, but I'll talk about that in a moment. For the most part, pointers, basically make a note somewhere of all the pointers you have in an object that you want to save, and then we'll talk about how that works a bit later. Okay, so once you've done that, once you've figured out which objects, well, which pointers you want to save, you'll have to create an object derived from, I think it's called USaveGame.8. Here it is. Yeah, USaveGame. Here it is. So you make your own custom save game object, and there's no real CPP file for this. It's just a header, and you want to make a series of structs for each of your object types or object categories, or even classes, I suppose, that you have in the game. So for example, we have our basic actors, which are buildings and our resources. And then we have controller, save data, we have characters, the characters in our game, and we have a bunch of other stuff. And so these structs that you create inside this save game object file, these basically refer or they capture that pointer data that you can't save using the save game U property argument. Every single one of these objects will have the class, the actor class, which as you can see here is a T subclass. Now you can, and I have seen people do U class, so instead just writing U class here instead, which I think works fine, but my understanding is that it's generally a bit safer if you use a template, a class template, and so I always go for T subclass of. You're also saving the transform of, assuming you want to save the transform of that particular object. And then, so those two things will always be at the top of each, except for actually controllers, because controllers you don't really need to give a transform. That shouldn't really be in here, because the transform of a controller doesn't matter. But certainly for characters and for your basic objects, things that you want to place in the world, they will have these two elements to them, the class and the transform. So once you've done that, you've gone through and you have made your structs. The next stage is to go into, to have a, assuming you haven't set this up already, to have a custom game instance class that you define. And in game instance, you'll have a write save game file. And this is going to get called from the UI. So let's have a look at our UI. So I'm not going to explain too much about how the UI works. I assume you either know, or if you don't, there are thousands of YouTube tutorials on YouTube and beyond. But once you've figured all that out and you have some kind of game saving system set up in the UI, this is our little function that saves games. So the first thing it does is it checks if the name that you've entered is valid. This is here because we had some issues when we entered some special characters. I can't remember what we used. Maybe it was a hash or something like that, and it just didn't save, and it didn't give any error messages. So now we just make sure that it is alphanumeric and it's under a certain amount of characters. Once we figure out, I couldn't find anywhere what exactly characters you are supposed to use or not supposed to use, but yeah, you can have this little function. You can define that how you want. So that spits out, is that a valid name, yes or no? If it's not, it puts a little error message up. Next thing to do is to check if your saved game exists. And so this is a gameplay statics function, an Unreal Engine function that basically looks through your save games and says, do we have a save game of that name? User index, also known as slot. You'll see it here, slot. I have absolutely no idea what this is used for. It doesn't seem to make any difference at all. I've read that for certain platforms it's relevant. It seems to not be relevant as far as I can tell. So I'm not going to say ignore that, but I've been ignoring it, and everything's been fine so far. So it checks if it exists. Obviously, if it does exist, you might want to overwrite it, and so we have a little overwrite message come up. And if it doesn't exist, then you would just write to the save game. So into this function that writes the game. So this is the function that gets called from the UI. The first thing it does is it checks if we have a current save, which is a reference to our custom save game object. Do we have one of these loaded already? If we do, and it's the same, then it will do some stuff. If we don't have a save loaded already, we'll check if the thing exists or not. If it does exist, then we'll load that save from the object. And if it doesn't, if there's no current save load and the game doesn't exist, then it will create a new one. And you can see that this function here, gameplay static, just creates one for you using the custom class that you've created, and loads that as our current save variable inside our game instance, and then it sets our name here. Now, coming back to the issue of pointers, a way that I thought it would be good to solve this problem is to use Unreal's inbuilt GUID system. So every object in our game that we want to save has creates at begin play a new GUID, which is a unique identifier. There's a very, very tiny chance that this ID can duplicate. So it works as a really good identifier for any object you have, a unique identifier. And so you'll see that if we go back to our save game header, you'll see that we have a lot of GUIDs in here, right? So basically all of our objects in the game that are pointers that we want to save somehow, we basically will save the GUID instead of trying to save the pointer. And that way, once the game loads, we can do a cross-reference once an object is spawned into the game and say, does this saved GUID correspond with one of the loaded objects GUIDs? If it does, brilliant, assign that object to this particular variable. And so that's the way we basically solved this issue of how to save objects, usually using GUIDs. Another useful, this is a really interesting function. So you iterate through every single object in the game. Very good one to know. And then we can save that as or recast that as an actor pointer. We also do a check to see if when we're saving, if this is a valid actor. There's a 0 chance, I think, that it's going to be a null pointer, but it may be that one particular object is in the process of being destroyed by the engine, and that can cause all kinds of problems. So yeah, this is valid function, just checks for both of those factors. Assuming all is well and good, we also have created an interface, which I had open, but then closed again, which is basically a bunch of functions that collect data, not the save game data that we mark in the U property, but this more complicated data. We pass in a reference to one of these structs, and it fills out the struct and spits it back and says this is all the data that we need. And so every object we want to save has this interface. And so the first thing we do is we say, does this object have this interface? If it does, then we set the ID of a blank ID at the moment of what the object is going to be, the ID of the GUID of the object. And then we go through and we basically do different things for different types of objects. So this is every character in our game derives from this class. So we'll create an empty struct, and this is the struct that we saw here, the character save data. We create this struct, an empty struct, and then we call the interface function for the character with that struct in, which feeds through to this function here. And so this function, it fills out the actor class, it fills out a bunch of the ID, the GUID, the transform, and some other stuff that we need. I'm going to show you in a moment the player inventory to show you how that looks like. Let me just show you that now. So yeah, we have an inventory. It's a very common feature in a game, so I figured this would be a good example to show you. And you can see it's very, very simple. We basically create an array of another custom struct, which is in our save game data. Inventory, item save data. Right? It's very simple. It just has the ID and the class, and whether it's currently equipped or not. And sorry, I didn't mention this before, but yes, you do need in every one of these structs and also an item byte data or some specific byte data, which is a theory of uint 8. And basically all of the serialized data, all of this stuff and the save game view properties are serialized into this array. And this array, if you open up your .sav file, once it's saved, this is what you'll see. You'll just say, see this byte data array. And then once it's deserialized, once you load the game, then it opens up, or it translates this unit 8 data back into your GUID, your classes, your booleans, your ints, all that kind of stuff. So yes, you do need to make sure that you have that in all of your structs as well. So back into our inventory, yeah, so we create an array of these item save data structs, and then you go through all of the items in your inventory, and again you just assign the ID, you assign the class, and again we've got some other information that you need in here. And this serialization process we actually don't need here. I'll show you this in a moment. And then it returns that back to our character, and it saves that array of item save data into our character save data. So that array is inside the character save data, and this is filled out and gets sent back to game instance. So it gets the save data here. It fills out this struct that we need. Now, this is a useful part to know. So the way, okay, so the saving character only wants to save, or rather the saving character, the saving player, only wants to save information about his or her own character. They don't want to save information about other players in the game. Other players will be responsible for saving their data, whilst the player is exclusively responsible for saving their own data. And so for that reason, passed into this function is the GUID, the unique ID of the saving player. And so then it checks, are you a player character? This is our class for our characters. Do you have the same ID as the one passed in? If you do, then it saves it very specifically to a variable, going back to our save game, with all of our structs. And at the bottom, we have some non-structs, which is the timestamp, includes the save name, slot, and also includes the reference of our player character, saving player, sorry, here, saving player controller, and that's it. And it uses that again to respawn the character in the character's specific location. So yes, we save a reference, specific reference to which character it is, which character it is that needs loading. And then if it's not a player character, then it will do other stuff. So you notice here that if it is a player character, it only saves information about the player that has this ID, and it ignores all the others. If it's not a player character, if it's another character, an AI, then it does almost the same. And notice here, this is a really, really important part of how I've built the system. We have a map here, all that data, where's that? Here. So this is a map that consists of a GUID first and foremost, and then actor save data. And what we do here is we save, once the character information, character data has been extracted, we'll then save or add an element to that map, which consists of the game ID and the actor data. We fill that out here, the class, the transform. And the reason we do this is because when we load up the game, as I explained before, you save this data to the save game file, save game object, and then once the game is loaded, it passes in that data and says, right, so you have this ID for example, this item. Let's use a different example. For this building, has there been a building loaded that has this ID? If it does, then get the reference to that building and then assign a reference to that building as whatever variable you want it to be. And so once we have extracted the data, we will go through the data and add an element to this map. And once we've done that, we say, okay, the ID of this particular iteration, particular actor is this. And then we're keeping tabs of how many actors we're saving. And so we increment that number here, that in here. And then we're doing the same for our resources and buildings. It's the same idea. There are just different variables that we've got. This is not really necessary. And then once we have all of our objects, once that's done, we make sure that we have assigned this actor to this map, and we serialize. Now, serialization. This is all fairly standard boilerplate code. You have to have what includes do you have for this one? I think it's these two, serialization, right? So make a note of these header files. So there's the way this works here is, yeah, so firstly you write it to memory using the byte data that we talked about, right, within your struct. That does some stuff. And once that stuff's been done, you have to set save. This is a really, really important part. Save game equals true. If you don't set this to true, then it basically saves everything. It tries to save every object in your header file marked as a U property, rather than just those variables that have been marked as save game. So this ensures that only the save game, or those objects that you've marked, those variables that you've marked as save game are saved. And then once it does that, you just call serialize on your actor, putting in this R. You can call this R. AR is the standard, but I've got all here because I've changed the name a little bit. And this process here, this function will, as I said, move all of that data from here and here and here and here and here. No, from here, here, and here, and here, and here, and here, all into your little byte data file array. And then once that's done, we are taking that map and we're saving it to our save game object, to a custom variable we have, all actor data, I think it's called, all actors. And then once that's done, we're going to save our framework data. So game mode and game state, we have a variety of variables that we want to save. And at the very end of everything, we make sure everything is serialized, and then we save that struct to our current save, our framework data and our current save, and then we call a function which writes save to disk. And the reason I've written a separate function for this is just in case there are some kind of network delays where you call these functions and it doesn't, you don't get the data back in time. You pass in how many actors we have saved. Remember that we increment this every time we save an actor. And then it calls this function, and this is a recursive function that basically checks, do we have, are all of the actors that we have, do they correspond to the actors that we have said that we should have? If they do, go ahead and save. If they don't, then call this function again, and we have a little timeout just in case something goes wrong. Yeah, so assuming that that all corresponds well, we've also added a little timestamp in here, which yeah, gets the time, saves that as a variable also inside this save game object, and then we simply just call this uGamePlayStatics function, save game to slot. We pass in the current save, which is our save game object, the save name, which is string, and the slot, and then that's done, and then it saves it automatically into here. You can see it's in, if you go into your main directory, saved, save games, and here is our wonderfully named save game files. If you try to open one of these up, try and do that, it's mostly garbage. You need a different program to really see it, but you can see here there's just a load of something that looks broadly like it's our variables in our game. That's all the save game is. All right, the last thing to very quickly talk about is as we're talking about multiplayer, we need to very quickly talk about the differences between the server saving and the client saving. So if we go back to the UI here, we can see that we call a function which is actually in our character class called WriteSaveGame. So let's open that up. And here it is. So you can see in here, the first thing we do is we check what role the character has, the player has. If your local role is authority, then you are the server. If not, then you are going to be the client. This took an embarrassingly long time to figure out, but actually, if you only want to save all of the objects in the game if you are the server, right? Because you're the one who's always going to be doing the hosting. Whereas if you're the client, all you really care about is yourself. You can be selfish. And you just need to save your own items, your own transform, things like that. And I guess any variables that you might need to repopulate. That's all you need to do. You don't need to worry about anything else in the game. So we have two separate functions, one if you're the server and one if not. So if you are the server, if you are the host of the game, then we call this function that we just went through directly. Otherwise, we call a local function, WriteSaveGame, which basically does the same thing, but again, only for your own data, for our character data, right? Again, we're not going through and checking the buildings and resources and everything else you have in the game. You just go through and you get your character data as you did before. You get your controller data if that's what you want. And again, we're doing the timestamp, we're serializing, and then we're saving like before. So that's just worth noting that you only need to do this big function. And so, yeah, just need to make sure that you're checking. You can do it in the UI as well. I believe you can do local role. And yeah, you can check here what particular role you want, right? I've just done it in here. I just prefer doing things in C++ generally. And so that's it for the first part. So that's save game. The next part, load game, is slightly more complicated, so I'm going to do that in a separate video. But for now, I hope this was useful. If you would like to check out the game, we have a link, I think, down below to our Discord. Nothing has really whet your appetite in this video, of course, because you're just looking at some UI and raw code. And of course, if you enjoyed this, please feel free to like, subscribe, all the usual hullabaloo. All right, till the next video.